start by plotting in number 4. We did number 3 already. So here we go. We're going to plot these points in number 4. Now, the first thing you see is that you have this point -1, 30. The -1 should bother you because you should be wondering, how can the radius be negative? Did you turn this on? How can the radius be negative? It can't. Remember, this is the point r, theta. The radius can't be negative. So what am I going to do with this? How am I going to plot this point? Well, I'm actually going to plot it at 1, 210. Now, how did I get the 210? Jack? It's the opposite of 30. If you think of opposite angles, how far apart are opposite angles? 180 degrees. Aren't they halfway around the circle? Now, somebody said 90. This angle and this angle are 90 apart. Are they opposites?
No.
No. Somebody said 360. This angle and this angle are 360 apart. Are they opposites? No. If we want the opposite of this angle, it would be this angle, the exact opposite direction, right? What's the opposite of left? Right. What's the opposite of up?
Down.
Down. They are 180 degrees apart. So if we want the opposite of 30 degrees, it will be 180 degrees different, which is 210. So we're going to plot point E is plotted at 1, 210. So that would be right here. This is point E. It is plotted on the first circle out, 210 degrees.
How do you know that it's the opposite though? It's not negative or anything.
Yes, it is negative.
Oh, the negative
It's
point.
negative. The negative radius tells you to plot the opposite angle.
I got you.
Okay, F. Now F is a different scenario. F is not a negative radius. F is a negative angle. Well, we can do negative angles. Negative angles just mean go this way. So this would be -15, -30, -45. So point F would be plotted on the second circle out at -45 degrees.
Okay.
That is a different situation than having a negative radius.
Quick question. So on the thing, it doesn't have 35, 45, so would it be where 300 would be? That's what 45?
No. Each mark is 15 degrees.
Okay,
Each mark
yep.
is 15
Okay,
degrees.
I see it. You just go the opposite direction.
Yes, the opposite direction. Now, the next one, G, we're back to another negative radius. You can't have a negative radius. You can't graph on a negative circle. So we have to rethink that point. A negative radius tells you to go to the opposite angle. So what angle is opposite 90? 270. So we're going to plot 3, 270. So there's point G. On the third circle out, 270 degrees. And H is the same situation. -5 pi. Well, that's radians. What's pi? 180. So what we really have is -5, 180. But we can't graph a negative radius. What is the opposite of 180? 0, or if you want to do 360, it doesn't matter. So that point's going to get plotted right here. Here is point H. When the radius is negative, we plot the opposite angle. And by opposite angle, we mean 180 degrees. Different. Okay. Now we need to get out our calculators. We're going to do some sketching.
It's over there underneath the
I don't know where the others, but I think.
Okay.
What'd you do yesterday, Miss Ford? Just get better? Hang out? Rest up?
Get better.
She was sick, Bud.
Oh, that's,
Yeah. Smart out.
Are you gonna use the Alamo?
No, it's not set up. I just thought I'd move it over here, and maybe I'll use the next.
We're gonna use the Elmo today?
Okay.
No.
Okay.
Love the Elmo.
Let's turn our calculators on. If you do not have a calculator, because you are once again not prepared for class, I need you to sit next to somebody who has one.
ladies.
I am not going to be going through this multiple times, so I need it quiet and I need you paying attention. First thing I want you to do is in mode. Everybody press mode. Click down to, it's FUNC, and next to that's PAR, and next to that's POL. We want POL because that stands for polar. So we are in polar mode. So highlight polar. And then make sure degrees is also highlighted. Make sure you're in degrees. So we want to be in degrees, and we want to have polar highlighted. Okay? Now we're going to go to our window. For theta min, put 0. For max, put 360. Because I'm in degrees, we set our calculator in degrees, 0 to 360 will take me once around the circle. For theta step, put 5. For x min, put -6, and x max, put 6. And x max 6. For y min, do also -6 and 6. So y min -6, y max 6. In the scale, just leave it 1. It should be 1 already, just leave it 1. Okay, now we're going to type in the first equation in problem 5A, which is r equals 2 cosine 3 theta. So type 2 cosine 3 theta. Now, the theta button is your X button. Just your regular old X button right there. So type 2 cosine 3 theta and hit graph.
I didn't get none.
So 2 cosine 3 theta. Where's the theta?
It's just the, like,
Okay.
you didn't put an equation.
Oh, that's right.
Type, go to R, or go to Y equals, and type in your equation, 2 cosine 3 theta, which is the first equation in 5A there. And you should have gotten what we call a rose.
I got a row.
You should have gotten a picture that looks like this. Did you get a picture that looked like that? That is called a 3-leaved rose. A 3-leaved rose. The questions that you are answering, how many leaves? 3. How long are they? Can you tell, or do you have a guess? From the equation, maybe. They're 2 units long. So for this equation, we have 3 leaves, and they're 2 units long. Okay? Now, let's take out that equation and let's put in the next one. 4 cosine 2 theta. What happened? You got a shape, hopefully this time, that looks like this.
I like the way it swirls around.
So for this equation, 4 cosine 2 theta, you got a rose. How many leaves?
4.
4. And how long are they, do you think?
4 units.
4 units long, very good. All right, let's try the next one. What did you get here? It has 8 leaves, and they're 3 units long. In a minute, I'm gonna ask you to make an observation, guys. So let's see. Let's do the last one.
Math is sometimes beautiful.
How about that last one? 5 sine 5 theta. Anybody have that one yet?
5 leaves, 5 units long.
5 leaves, and they're 5 units long. Okay, now
Okay, now that one's weird.
we're going to make an observation. Let's suppose, do not graph this one. Do not graph it. If I said to you, how long are these leaves? You would tell me 4. Because the length of the leaves is just this number right here. This number is the length of the leaves. Whatever the first number out in front there is, that's how long the leaves are. Now, if I said how many leaves, that's a little trickier, because this one had 5, and this one had 3. But this one had 8, and
That one had 4.
This one didn't have 4.
It says 4 leaves right there.
I know, but it didn't have 4. 4 cosine 4 theta?
We didn't do that one.
It's 2, it's 1 cosine 2.
Oh, was this a 2?
Yeah.
Yes, okay, and it did have 4, yeah. That had 2, there was a 2 there, but it had 4 leaves.
I think I see the
Okay,
pattern.
so wait a minute.
Do the page.
What seems to be going
It's
on?
double.
Yeah, I got it.
Okay, if the equation is 4 cosine 2 theta,
Oh, yeah.
it had 4 leaves. That's what was on the paper, I copied it wrong. 4 theta would have 8 leaves.
Okay.
This one had 8 leaves. This one had 4 leaves. But this one had 5 and this one had 3. What seems to be going on?
Odds don't double.
Exactly. If this number is odd, that's how many leaves there are. So 7 theta would have 7 leaves. 11 theta would have 11 leaves. But if that number is even,
Then it's double.
then it's double. So 4 theta has 8 leaves, and 6 theta would have
12 leaves.
12 leaves.
12 leaves.
So now, we could have a quiz question without a calculator, where I said something like, R equals 10 sine 14 theta is a rose. How long are the leaves?
10.
And you would say 10. And I would say, how many leaves are there?
28.
And you would say 28. Got it?
Big picture.
Okay. Next section. Now we're going to sketch a different kind of picture. So we're going to leave our window, we're going to leave everything the same, but now we're going to type in this equation. You are not going to get a rose. Type it in. Tell me what you get.
I don't know what to call this.
I'm not a very good drawer.
Great.
It looks beautiful to me. That looks beautiful.
Did you get something that looked like that?
Yeah.
This shape is called a limacon. And it looks like a lima bean. Very good. So you'll remember limacon. The roses, the things we just got done, those are the things that look like daisies. You know, they got petals that look like daisies.
They're really beautiful.
These do not look like daisies.
They're ugly.
This is a limacon.
It's too
Now, I want you to go ahead right now and sketch C, not B, do C. Because something different is going to happen
Something's about to go down.
with C. So go ahead and sketch that one.
Oh.
Yep.
Now,
It's no.
did the top of it go off?
No.
Okay, so let's go to our window and let's set Y max at 10. Set Y max at 10, and that way you'll be able to see the top of the picture.
Wait, what?
Set Y max at
I
10.
didn't have that
I don't know where it's
Now, what's different about the picture that I have on my screen now than the one that I had up here? The little loop is gone. Now, it's also situated differently, but this one has the indentation, but it doesn't have that little loop in there. There's no loop in it. This shape is called a cardioid. It is a special lemmason. Now listen to me. Both of these are lemmasons. That is a special one. It is called a cardioid. It looks like a heart, right?
Or heart.
Now, the reason that one is a heart is because in the equation, Maya, please be attentive, thank you. It has this equation. Notice these two numbers are the same. That was not the case in our first problem. If these two numbers match, you will have a cardioid.
Why are some of them sine and some of them cosine? Is that just what the problem is?
Yes, and it doesn't matter. It has, so like this one, kind of lima beamed this direction because it was a cosine. This one lima beamed this way because it's a sine.
Oh, I see.
So it's gonna change the orientation, but not the shape. Okay, so I wanna go back to this one more time. And when I look at number 6, part 6, on my note sheet, page 52, all of these are lemmasons in part 6. Every single one of those equations is a lemmason. Which ones are going to be cardioids?
C and D.
C and D. Because C and D have the same number. Now, sometimes it's addition, sometimes it's subtraction. All that does is change the way it's oriented. It doesn't have anything to do with its shape. So C and D would be cardioids because they have the same number in the problem. A and B do not have the same number, so they would not be cardioids. Okay, next. Now we have a couple of trickies.
What time do we get out of this class? Forced to leave. Forced to leave.
Okay, we have to hurry up, we're a little bit behind. This is gonna be the last sketch we're gonna do right now because we're gonna do a couple other things. In order to put this into my calculator to graph it, I have a problem. What's the problem?
It's squared.
It's R squared. So I'm gonna need to take the square root. Now, pay attention. This is going to go into your calculator as two separate equations. It's going to go in as the positive square root and the negative square root. Sometimes you don't need both. Sometimes you do. Since I never know, I always put them both in. When you type the square root sign, a parentheses will automatically come up, doesn't it? Nope, then put it in because you need it. Because this entire thing has to be in parentheses. You're taking the square root of that whole thing. And then you'll type negative radical and the same thing. Put in both of those equations and tell me what shape you get.
The same line or two different ones?
They're two different equations. They're two different equations.
Alright, in oval.
Shouldn't be an oval.
I got it.
You're like two O's, like a little weird A.
So you got two O's?
I got a
That's
weird
what you
A.
should get, yeah.
Weird A.
I heard somebody say at a figure 8, you should get a figure 8 shape. Now, it doesn't look perfect because of the way we have our windows set up, but you should have a shape that looks something like this.
Okay. Haley, I typed it incorrectly.
This curve is not a rose, and it's certainly not a lemmason. This is called a lemniscate. A lemniscate is a figure 8.
I might name my daughter that. That sounds murder.
Now, we will graph more in the coming days because we still have to do number 8. Number 8 is the really fun one, but I need to do a couple of things. You said the bell rings at 9:10?
Yeah.
Okay, then I need to do that. I don't know. Now, shh. Quickly, 9A. This is in your homework tonight, so I gotta make sure we get over it. 9A, this is not graphing. In 9A, we are changing to rectangular coordinates, or rectangular equation. Now listen, this is easy. Back in chapter whatever, a long time ago, what did you memorize for cosine? What was your definition for cosine? Okay, one definition was adjacent over hypotenuse. What was another definition? X over R. So I'm going to take that cosine and I'm going to change it into X over R. If you have forgotten that definition, then please write it down over to the side so that you can remember it again. I'm simply taking out the cosine and replacing it with X over R. Now I have a fraction. So I'm going to multiply both sides by R. So I'll have R squared equals 3x. Now a couple days ago, you memorized something about R squared. In fact, we took a quiz about it. What's R squared? X squared plus Y squared. Thank you, Brooke. Here is your answer. Now, I want you to look at what you started with and what I ended with. What are the variables in this top equation?
R.
R and
Theta.
theta. So this is a polar equation. What are the variables in our answer down here?
X and Y.
X and Y.
See what
And
you
your direction said convert to rectangular equation. We did that. So quickly, let's go through the same steps with letter B. So we are now on 9B. Here we go. What do you think we'll do first? What sine theta? This is a sine. It's not x over r, it's y over r.
think it's slick, huh?
Then what will I do next? So r squared will equal 2y, because I'm going to multiply both sides by r. What's r squared?
X squared plus Y squared.
X squared plus y squared. And there's your answer.
That doesn't seem too bad.
It is not bad at
Until
all.
tomorrow, we're gonna come up in here and you're gonna have to put some,
Okay.
now what you thought was easy.
And the last thing, 10A.
I'm gonna show you something.
This is really easy. On your quiz on Friday, or Monday, you had to tell me what you memorized. X equals R cosine theta. So instead of X, wait, R cosine theta plus 2 times R sine theta equals 3. And that's the answer. All right.
Whoa! Ow!
Right
as well.
Oh, I made it.
Never in a million years.